In the vast uncharted expanse of the cosmos, where stars burn with ferocity and mysteries linger in the shadows of the void, humanity stands on the precipice of a new era. On November 14th, 2023, a heart-stopping silence fell over mission control as Voyager 1, the farthest human-made object ever to pierce the veil of our solar system, stopped transmitting meaningful data. For months, it sent back only a cryptic stream of binary noise, a ghostly whisper from 15.5 billion miles away. The cause? A catastrophic memory failure in its flight data system, threatening to sever our connection to this cosmic pioneer forever. But the team of brilliant minds refused to surrender. On April 18th, 2024, they made a daring move, reallocating code to uncharted regions of the probe's ancient memory. The signal took 22.5 hours to reach Voyager, and another 22.5 hours for a response to crawl back across the abyss. Every second was a gamble, every attempt a leap into the unknown. Then, on April 20th, a miracle unfolded. Voyager 1 roared back to life, re-establishing contact with Earth. What secrets did this interstellar Voyager uncover at the edge of our solar system? Why was the boundary of our cosmic neighborhood so shockingly different from what we imagined? And what comes next in humanity's relentless quest to conquer the stars? The story of Voyager 1 and its twin, Voyager 2, is one of audacity, ingenuity, and unrelenting curiosity. Launched in 1977, these spacecraft capitalized on a once-in-175 years planetary alignment, a celestial gift that allowed them to slingshot through the solar system, visiting Jupiter, Saturn, Uranus, and Neptune in a grand tour that redefined our understanding of the cosmos. Voyager 1, racing at 38,000 miles per hour, outpaced its sibling, capturing humanity's first close-up glimpse of Jupiter's swirling storms and Saturn's intricate rings. Voyager 2, trailing at 34,360 miles per hour, ventured further, revealing Uranus as an ice giant with a frigid core and Neptune's vivid teal hues. Together, they unveiled 48 moons, discovered new rings, and confirmed phenomena like Europa's cracked, icy surface, hinting at a hidden ocean beneath. But their greatest triumph came when they pierced the heliopause, the boundary where the sun's influence fades, and plunged into interstellar space. Voyager 1 in 2012, Voyager 2 in 2018. The heliopause was not what anyone expected. Scientists once believed the solar wind, a torrent of charged particles from the sun, would gradually weaken, fading into the interstellar medium. Instead, the Voyagers revealed a sharp, dramatic boundary, a cosmic wall where solar plasma collides with interstellar plasma, creating a turbulent traffic jam of particles. The heliosphere, the sun's protective bubble, stretches 11 billion miles, but its shape is bizarre. A sphere on one side, a long tail on the other, distorted by massive waves that ripple across 10 astronomical units, nearly 1 billion miles. The data was mind-blowing. The interstellar magnetic field is 2 to 3 times stronger than predicted, exerting 10 times more pressure on the heliosphere. The temperature and density of the solar wind near the heliopause, 10 times lower than expected, defying every model. Where does this missing energy go? The answer remains a tantalizing enigma, a puzzle that challenges everything we thought we knew about our solar system's edge. But the Voyager's story is nearing its end. Their plutonium-powered generators are fading, and by 2030 their instruments will fall silent, leaving them to drift eternally through the interstellar void. In 40,000 years, Voyager 1 will pass within 1.7 light-years of a star in Ophiuchus, while Voyager 2 will graze Ross 248 in Andromeda. Each carries a golden record, a cosmic message in a bottle with sounds of Earth, whale songs, human voices, music, and greetings in 55 languages. If an alien civilization ever finds them, they'll hear humanity's heartbeat, a testament to our ambition. But as these pioneers fade, a new chapter begins. Space Race 2.0, a relentless push to explore beyond the heliosphere, to unravel the mysteries of the cosmos, and to answer the ultimate question, are we alone? The original space race, ignited in the 1950s, was a clash of superpowers, a Cold War battle for supremacy that launched Sputnik, landed humans on the moon, and birthed the Voyagers. Today, Space Race 2.0 is a global, collaborative, and commercial endeavor, driven by a mix of government agencies, private companies, and visionary billionaires. The stakes are higher, the technology more advanced, and the goals more audacious. NASA's Artemis program aims to return humans to the moon by 2026, establishing a lunar gateway, a space station orbiting the moon, to serve as a staging post for Mars. By 2035, astronauts could walk on the red planet, searching for signs of ancient life in its dusty craters. But the real frontier lies beyond, in the interstellar realm the Voyagers first touched. In 2030, NASA plans to launch the Interstellar Probe, a spacecraft designed to travel 10 times farther than Voyager 1, reaching 1,000 astronomical units, 93 billion miles, in just 50 years. Unlike the Voyagers, built with 1970s technology and 69.63 kilobytes of memory, less than a modern emoji, the Interstellar Probe will harness cutting-edge propulsion, possibly nuclear-powered, to achieve speeds of 100,000 miles per hour. Its mission? To capture the first comprehensive portrait of our solar system from the outside, study the heliosphere's interaction with interstellar space, and probe the local bubble, a 1,000-light-year void carved by ancient supernova. This bubble, discovered through advanced simulations by the Harvard-Smithsonian Center for Astrophysics in 2024, surrounds our solar system, a cosmic cradle where stars are born on its dense edges. The Interstellar Probe could reveal how these bubbles shape the galaxy, offering clues to the origins of life itself. Private companies are rewriting the rules of exploration. SpaceX, with its Starship, aims to colonize Mars, deploying mega-constellations of satellites to provide global internet and fund interplanetary ambitions. By 2028, Starship could ferry cargo to Mars, paving the way for human settlements. Blue Origin's New Glenn rocket, set to launch in 2026, promises reusable heavy-lift capabilities, while companies like Rocket Lab and Astra are slashing launch costs, making space accessible to startups and universities. In 2024, SpaceX's Starlink network reached 5 million users, proving private industry's power to scale space infrastructure. Meanwhile, China's Tiangong space station, completed in 2023, hosts experiments in quantum communication, and India's ISRO plans a lunar rover by 2027, joining the global push. The search for extraterrestrial life drives this new race. In 2025, NASA's Europa Clipper will arrive at Jupiter's moon, drilling through its icy crust to sample its subsurface ocean, a prime candidate for microbial life. The James Webb Space Telescope, operational since 2022, has already detected biosignatures, molecules like methane and oxygen, in exoplanet atmospheres 1,000 light-years away. By 2030, the European Space Agency's ARIEL mission will analyze 1,000 exoplanet atmospheres, hunting for signs of alien biology. The Voyager's golden records were a passive message. Space Race 2.0 is an active hunt, using AI-driven telescopes and probes to scan the cosmos for signals. From radio bursts to technosignatures, evidence of alien technology. But the cosmos is not silent. In 2021, Voyager 1 detected a haunting hum, a steady 3 kHz plasma wave persisting for 3 years, 14 billion miles from Earth. Scientists believe it's the vibration of interstellar plasma, but some speculate an unknown energy source. Fast radio bursts, FRBs, discovered in 2007 and numbering in the thousands by 2025, pulse for milliseconds from billions of light-years away. Are they natural, from neutron stars or black holes, or artificial misaimed signals from alien spacecraft? On Mars, NASA's Perseverance rover recorded a chilling high-pitched scratching in 2021, still unexplained. These cosmic symphonies hint at a universe alive with activity, urging us to listen closer. The challenges are immense. Interstellar travel demands propulsion, breakthroughs. Chemical rockets, like those powering the Voyagers, are too slow. A trip to Alpha Centauri, 4.37 light-years away, would take 80,000 years. Nuclear thermal propulsion, tested in 2024 by DARPA, could cut that to decades, while concepts like laser-driven light sails, proposed by Breakthrough Starshot, aim for 20% of light speed, reaching Alpha Centauri in 20 years. Radiation in interstellar space, 1,000 times stronger than Earth's, threatens electronics and astronauts alike. The Voyager's survival owes to their simplicity. Modern probes need advanced shielding and AI to navigate autonomously as signals take years to cross the void. Space Race 2.0 is also a race against time. Climate change, geopolitical tensions, and resource scarcity demand that humanity become a multi-planetary species. By 2040, SpaceX envisions a Martian city of 100,000 people, sustained by hydroponics and 3D-printed habitats. Asteroid mining, led by companies like Astroforge, could yield trillions in rare metals, fueling a space-based economy. In 2025, the International Space Station will retire, replaced by private stations like Axiom's, already under construction. These outposts will test technologies for deep space survival, from closed-loop life support to radiation-resistant materials. The emotional weight of this journey is profound. The Voyagers, with their golden records, carry humanity's hopes, dreams, and fears into the unknown. They remind us of our fragility, a pale blue dot, as Voyager 1's iconic 1990 image showed, just 0.12 pixels in the cosmic tapestry. Yet they also reflect our audacity, our refusal to be bound by Earth. Space Race 2.0 is not just about technology, it's about who we are. Every launch, every discovery is a declaration that we will not go quietly into the night. We will explore, endure, and perhaps find others out there staring back at their own pale blue dots, wondering if they too are alone. The local bubble, our cosmic neighborhood, is a testament to the universe's violent beauty. Formed 14 million years ago by 15 supernova explosions, it spans 1,000 light-years, its edges glowing with star-forming clouds. The Sun, orbiting the Milky Way's center every 200 million years, drifted into this void 5 million years ago, a safe haven where cosmic rays are tamed and Earth's life flourished. But the bubble is expanding at 4 miles per second, reshaping the galaxy. The Interstellar Probe will map this bubble, revealing how supernovae sculpt the cosmos and how our solar system fits into the galactic puzzle. Beyond the bubble lies the Milky Way's spiral arms, dense with gas and stars. When the Sun crosses these arms, as it did 415 million years ago, mass extinctions followed, linked to cosmic radiation spikes. Today, in the local bubble's calm, humanity thrives. But the cosmos is indifferent. An asteroid, a gamma-ray burst, or a rogue black hole could end it all. Space Race 2.0 is our insurance policy, a bid to spread humanity's light across the stars before the next cosmic upheaval. The technology propelling this race is staggering. In 2024, SpaceX's Starship completed its first orbital refueling, a game-changer for deep space missions. Ion propulsion, used by NASA's Psyche mission to a metal-rich asteroid in 2023, offers efficiency for long-haul probes. Quantum computers, now in early commercial use, could optimize trajectories and decrypt alien signals. In 2025, China tested a hypersonic spaceplane capable of reaching Mars in weeks. Meanwhile, 3D printing in microgravity, perfected on the ISS, will build lunar and Martian habitats, while synthetic biology could engineer microbes to produce oxygen on alien worlds. The economic stakes are astronomical. By 2030, the global space economy could hit $1 trillion, driven by satellite networks, space tourism, and resource extraction. In 2024, a single asteroid, 16 Psyche, was estimated to contain $10 quintillion in iron and nickel. Private companies are racing to claim this wealth, while nations like the UAE and Japan invest billions in spaceports and probes. But with opportunity comes risk. Space debris, now exceeding 30,000 trackable objects, threatens satellites and stations. International treaties, like the 2024 Artemis Accords expansion, aim to regulate lunar mining and prevent conflicts. The search for life is the race's heartbeat. In 2023, the James Webb Space Telescope detected dimethyl sulfide on exoplanet K218b, a potential biosignature. By 2035, the Large Ultraviolet Optical Infrared Surveyor, LUVOIR, will scan 50 nearby star systems for habitable worlds. On Mars, NASA's Sample Return mission, set for 2028, could confirm fossilized microbes. The discovery of life, even a single bacterium, would rewrite our place in the universe, proving we're not alone. But what if we find intelligence? The Voyager's golden records assume a friendly encounter, but SETI's 2025 protocols prepare for hostile signals, a chilling reminder of the unknown. The emotional pull of this race is universal. In 1977, as Voyager 1 launched, humanity was fractured. Cold War tensions, economic strife, and environmental fears loomed. Yet, those two probes united us, carrying our collective story into the stars. Today, as we face climate crises and global divisions, Space Race 2.0 offers hope. It's a chance to transcend borders, to unite as a species, to dream bigger than our pale blue dot. Every child gazing at the stars, every engineer coding a probe's path, every scientist decoding a cosmic hum. They're all part of this saga. The Voyagers taught us that the universe is stranger, wilder, and more beautiful than we imagined. They found volcanoes on Io, oceans under Europa, and a heliosphere that defies logic. They heard the cosmos hum, a siren call from the void. Space Race 2.0 will take us further, to the Oort cloud, 30,000 years away, where comets dance in a trillion-strong swarm. It will push us to Proxima Centauri, where a habitable exoplanet might await. It will answer whether the universe is silent or singing with life. Voyager 1's signal fades. It whispers a challenge. Keep going. The stars are calling, and humanity is answering. In 2030, the Interstellar Probe will launch, carrying our hopes beyond the Heliosphere. By 2050, we could have boots on Mars, minds on asteroids, and telescopes peering into the galaxy's heart. The cosmos is vast, but our ambition is vaster. This is Space Race 2.0, not just a race to the stars, but a race to become more than we are, to etch our story across the universe, one daring leap at a time. The journey is fraught with peril. Interstellar dust, though sparse in the local bubble, could shred a probe at relativistic speeds. Radiation spikes could fry circuits or mutate DNA. A single miscalculation could doom a mission, stranding billions of dollars in the void. Yet the rewards are unimaginable. A single discovery, an alien microbe, a habitable exoplanet, a new propulsion method, could redefine humanity's future. The Voyagers survived decades of cosmic bombardment. Space Race 2.0 demands probes that endure centuries. The public's imagination is ignited. In 2024, a viral X post showed a simulated view of Earth from 1,000 astronomical units, shared 10 million times. Space tourism, pioneered by Virgin Galactic's 2023 suborbital flights, now costs $200,000 per seat, with 1,000 passengers annually. By 2030, orbital hotels could host thousands, gazing at Earth's curvature. These experiences fuel a cultural shift. Space is no longer a distant dream, but a tangible frontier, where anyone with enough grit or wealth can touch the stars. The political landscape is shifting too. In 2025, the US, China, and EU signed a historic pact to share lunar data, a rare moment of unity. But tensions simmer. China's 2024 claim to a lunar mining site sparked protests from India and Russia. Space Race 2.0 must navigate these rivalries, ensuring exploration unites rather than divides. The Artemis Accords, now signed by 50 nations, set rules for peaceful space use, but enforcement is shaky. A single spark, a disputed asteroid claim, a hacked satellite, could ignite conflict. The technology is evolving at breakneck speed. In 2024, a breakthrough in fusion propulsion at MIT promised reactors small enough for spacecraft, potentially slashing travel times to Mars to months. AI, now powering autonomous rovers like Perseverance, will guide interstellar probes, making split-second decisions when Earth is light hours away. Nanotechnology could build self-repairing hulls, while bioprinting might create organs for astronauts, solving long-term health risks. These aren't sci-fi fantasies. They're prototypes in labs today. The emotional stakes are personal. Every scientist who saved Voyager 1 in 2024 felt the weight of history. Every astronaut training for Mars knows they might not return. Every child dreaming of the stars carries humanity's hope. Space Race 2.0 is a collective dream, a refusal to let our story end on Earth. The Voyagers showed us what's possible with 1970s tech. Imagine what we'll achieve with 2030 innovation, a probe reaching Alpha Centauri in our lifetime, a colony on Mars by 2050. These aren't dreams, they're plans. The cosmos is a paradox. beautifully ordered, yet chaotically unpredictable. The Voyagers found a heliosphere that dances with interstellar plasma, a local bubble sculpted by ancient explosions, a universe humming with secrets. Space Race 2.0 will chase those secrets from the Oort cloud's icy depths to exoplanets light years away. It will test our courage, our ingenuity, our unity. The stars are not just destinations, they're mirrors, reflecting who we are and who we could become. As Voyager's signal fades, it passes the torch to us. The race is on, and the universe is watching.